Okay, this first problem, Nielson Media Research conducted a study of household television viewing times during the 8 p.m. to 11 p.m. time period. A sample of 35 was taken with the sample average calculated to be 8.5 hours. Based on past studies, the population standard deviation is assumed to be 3.5 hours. Develop a 95% confidence interval estimate of the mean television viewing time per week during the 8 to 11 p.m. time period. Okay, in this problem we can see that they're asking for a confidence interval, a 95% confidence interval. It's asking us for a interval estimate of the population mean television viewing time per week. So the mean. With the average, we've got to make a decision on the distribution that we're going to use, and that is primarily going to depend upon the standard deviation that we're given. And in this one, we are given the population standard deviation. So between the standard normal distribution and the t-distribution, we're going to use the standard normal distribution. So our formula is x bar plus or minus z alpha over 2 sigma. Sigma is the population standard deviation, and that's what we're given, so that's why we're using standard normal over the square root of n. So this is our formula for calculating this confidence interval, and we can just go ahead and try to find some of the values for this. The sample average x bar is given as 8.5 hours. Our sample size that we got that from is 35. Our standard deviation was the population, so it's sigma, and that was given at 3.5 hours. And we need the value from the standard normal table, the number of standard deviations. Now this is a 95% confidence interval, so alpha is 0.05. And we're going to be looking up z.025. And that actually is 1.96. So I'm going to go ahead and plug everything into my confidence interval formula. Okay, the first thing I'm going to do while building this is to find what's called the margin of error. It's basically the number that tells us roughly how far away the actual population average mu is from our point estimate of 8.5 hours. And calculating that, I get .16. So 1.16 is my margin of error. So while I'll estimate the population average viewing time per week at 8.5 hours, the real population average is within 1.16 hours of that. And then I can add and subtract that to my 8.5 to get the confidence interval 7.34 to 9.66. So I could say we are 95% confident. We have 95% confidence that the real population average number of viewing hours per week during the 8 to 11 p.m. time period. So 95% confidence, or we're 95% confident that the real population average number of viewing hours per week during the 8 to 11 p.m. time period is somewhere between 7.34 hours and 9.66 hours. And the key word there is the population average of all households. What is the average viewing time per week during that time period? We've only looked at 35 households as far as viewing time. We are trying to estimate the viewing time for all households, and we are going to estimate that with a sample average of 8.5. That's called the point estimate. That was based on a sample of size 35. Our margin of error says that that value could be as much as 1.16 hours off from what the real population value is. We know, in other words, that the real population average number of viewing hours per week between the 8 and 11 time period is somewhere within 1.16 hours of 8.5 hours, or somewhere between 7.34 hours and 9.66 hours, with 1.16 as our margin of error.